As we see in our title graphic, welcome to Let's Decode Together. We are tackling a specific persistent problem, LLMs confidently hallucinating when you ask them complex, multi-step questions. If you build enterprise AI, you know the reality. Users rarely ask to summarize a single document. They expect the system to connect distinct facts across millions of rows of data. This left panel illustrates VectorRAG. It's the industry's default architecture, relying entirely on semantic similarity matching. As noted by the Discovery Mode tag, this flashlight approach is effectively a vibe check. It's incredible for rapid discovery, but blind to explicit logical connections. Now look at the right panel. This is GraphRAG, an alternative architecture built to map multi-hop relationships. Notice the navigation mode at the bottom. Graph acts like a detective. It meticulously traces explicit links between entities rather than relying on broad topical similarities. This creates a difficult dilemma for developers. You have to decide whether to prioritize accuracy through GraphRAG or maintain the speed of Vector while accepting the risk of hallucinations. AI marketing hype often obscures the actual engineering costs associated with these two systems. Let's set up a high-stakes multi-hop query. Imagine asking an enterprise AI to list scientists who possess both a Nobel Prize and an element named after them. This top left section outlines how VectorRAG attempts to process this query. It independently retrieves documents about Nobel Prizes and chemical elements. The WED warning triangle highlights a critical flaw. With no explicit connection, the LLM must guess, directly causing high hallucination risks. Moving down to the GraphRAG section, it handles the same query, starting with a distinct node for Marie Curie. Following the relational arrows, the system executes an exact path traversal along verifiable edges to her specific achievements, winning a Nobel Prize and discovering polonium. The final output box shows the result. This rigid data structure removes LLM guesswork. It achieves high explainability because every answer traces back to a defined edge.